Got it.
Now find the wires leading from the timer to the detonator and cut the red one.
Carter. They're all yellow.
Say again?
There are 5 wires and they're all yellow. Maybe I should cut them all?
The thing is, sir, if you interrupt the wrong circuit, it's basically the same as telling the bomb that the timer has reached 0.
Yeah, I knew that.
Well, heidi-ho, neighborinos. Welcome back. This episode, we're going to start on some wiring. So the plan is run some USB cables and have to run the deck stepper motor cable and cables for the focuser and the rotator. Rotator I don't have yet, but maybe we'll build one of those. And also 12 volts going to the top of the mount so I don't have to have any wires hanging off. So let's hope I can do it, and let's get started. Go take a look. So let's talk about USB cables, or more importantly, USB 3.0 cables. So I thought when I was first designing this, well, USB 3, I know it has 9 wires. I had this fancy, really flexible silicone wire stuff, and it's even the right colors for a USB 3 cable. But the more I started researching, well, there's 9 cables, but 2 of the pairs have to be twisted. They have to be twisted at different rates. They have to be all exactly the same length. The pairs have to be shielded, and then the 2 pairs have to be shielded again. And then the whole thing needs to have a different kind of shielding on it. So I actually got some of this, which is some adhesive back shielding. I did have some of this braided tube shielding for the other kind. Then I thought, well, after I get all this done, my cables are going to be about that big around, so that's not going to work. So my next bright idea, I went to our surplus warehouse at my job, bought a few USB 3 cables. They're only $1 a piece at the surplus. My idea is to take one, I'll strip all the insulation off. I have my pairs here. So here's one pair shielded, here's the other pair shielded. They're both shielded together. Then I have the 4 regular wires for USB there for the power and all that stuff. And then it's shielded and covered in the braided tube. So it'll just be a little bit of intense soldering onto my ends, which I can probably do. So these are my ends. I have a couple of these for the one end with some little teeny solder joints. And on the telescope side, I just have this plug, and these will be easy to solder because it's just those. They're all numbered correctly. Then I had my friend Google Gemini help me out with the wiring. I don't know if any of you have made network cables or not, but this cable I'm making needs to be like a crossover cable like you make with network cables, which basically means you take a couple of the pair and you cross them on the other pins. So you'll take the receive and the transmit and put them on the transmit and the receive on the other end. So this tells me the pin numbers. And I learned a lot about ground drains and grounding. That's a different thing. So we'll be soldering all that on. And then the easy part, well, I have my RJ11 jacks. They're just 4 wires. They're for the power for the focuser and the rotator if I ever build one. And I also have the 12-volt jacks for the 12-volt end on my mount. So we're just going to wire all this stuff in. So big design change in the mount. After doing quite a bit more research, I found out that stepper motors are super dirty with EMI because of the pulse modulation that they use. So running that right parallel with my USB cable, I'm going to have to twist those pairs, shield that cable, and the 12 volts going to be the same. I'll have to twist that and shield it because they're running so close to the USB cable, or I'm not going to get the bandwidth I need out of the USB. So that's going to take up a lot of room through the middle of the mount. That means I will probably only have enough room for one USB cable. So that's just the way it's going to be, but I guess I'll survive with that because that one USB will plug into the power box that I have on top. So I still have plenty of USB ports up there. So continue on. Well, I've done some small scale soldering before, but this is scary. I hope it works. Okay, this is called liquid electrical tape. Comes in like a tube like this. Has a syringe-like applicator on it. You can squirt it in between all the little contacts. It flows in between everything, and then it dries hard. So, kind of sets everything in place. So, it'd be hard to pull out all the little connections. Now I just got to solder my braid onto the case here, and then I think I will wrap this part with some of that copper shielding tape I got, and then probably shrink wrap it. Then, well, shrink tube it, not shrink wrap it. So then I think that'll be a solid end. All right, hopefully that will shield. Now I'll just put some shrink tubing on it, and we'll have one end complete. Well, I guess so. Okay, so I have a bunch of these with really short leads. So I desoldered the wires, soldered some 18 gauge silicone with long enough to go through the mount. This will be my 12 volt up at the deck end. Silicone wire is really bendy in high temperature and low temperature. It's just a good wire. Shrink wrap them. I'll put this end in the vise carefully and then put the other end on my drill and do the twisty thing. Twist it up, and then we'll come back. Alright, so now we're going to move on to shielding. So for that, I have some braided shielding. It is 1/8 inch. And I'm going to show you how to, easy way to put this over the top of my twisted pair using a stick. So the thing about this braid is that when you compress it, it gets fatter. So we're going to use that to our advantage. So we'll take the stick, get it started here. Now we'll thread it on. And try not to poke it through. So this is kind of like a pair of those Chinese finger traps. And hopefully we can just fit it all through. Uh-oh. You don't want that to happen. Alright. I think I've got it. Now, I wasn't too impressed with that last shrink tubing I had. I did a little research and I came up with this. It's called Shrink Flex by Tech Flex. So it's really flexible and it has a 3-to-1 shrink. So it should make pretty tight cable. So we just thread this over and I use my little heat gun here off my soldering rework station to shrink it down. So we'll try that. Here we go. One fairly completed cable. Shrink pretty good. Still seems to be fairly pliable. So after we get this ran through the mount, find out exactly how long we need it, then I'll solder the other end on that one just like this side, and that'll be my 12 volt. Okay, so I have bent a cable making fool. So this will be the deck for the deck motor running up through the middle of the RA axis. I've used 22 gauge wire, twisted this pair and this pair. It is shielded, so hopefully that's gonna work. I have this wire, which I have not shielded, and it is 28 gauge wire. This is going to be for the focuser and the rotator lines for the on-step controller. They don't need to be quite as thick a gauge of wire because they're usually just NEMA 14 motors. I didn't shield this one to make a little more room through the axis, and I didn't think these would be running the whole time, just during a focus run, so that shouldn't affect the USB too much. And then I have this wire, which is 2 strands of silicone wire, 18 gauge, shielded, twisted. That's going to be for my 12 volt going up through the mount. Okay, now onto the USB. You have the USB all soldered, ran up through the middle of the mount, running down to there. So let me show you what I got to do a little continuity test with. Okay, here I have a USB cable tester. So we'll try a USB 3 cable here. Plug one end in there, the other end in to the B side, and you see it has all 9 lines there, and that one over on the side is the shield. So I've got 2 cables. I'm going to plug one end each end of my mount, and then I'll plug the 2 ends in here. Hopefully we get the same reading. There goes nothing. So I got one end in down there, one end in up here. All right, we got 9 lines. The shield is not showing. I don't have the shield soldered yet because I want to get this mounted first before I solder the shield. Okay, I'll just take a wire and jumper the shield, and hopefully it comes on. Good deal. All right. Next. So I have this self-adhesive insulating material that I'm going to line the bottom of that with so nothing touches what it shouldn't. This is pretty tough stuff. They use it for making lithium-ion battery packs for solar things, stuff like that. So hopefully nothing will short out. And then we'll have to work on the stepper motors. Alright, finally got the control plate for the mount 3D printed. I designed it in Tinkercad, then pulled it into Ultimaker Cura, did the slicing, then I printed it on the printer we have at work, which is a old Anycubic Cobra 2 Max. Not the best printer, it's old, but it works. Not quite sure what this little lump there is, but anyway, so I got power switch, USB port, 12 volt input, 24 volt input. This is for like an RS-232 serial port and an ST4 port, which I'll never use, but I left the opening there just in case. This is the input for the USB for the on-step controller, which is a micro USB, couple of LED ports. So we'll see if all of our stuff fits on here, and we'll continue on. A milestone has been reached. All the wiring is done. I don't know if you can see back in there, but all the ports are done. I don't know if you can see back in there, but all the jacks are wired up. We got power to the main board here, power to the brake on the stepper, all the wires up here. You can see I put a ferrite module on the deck stepper, same on this side. Supposedly that cuts out a little more noise. I don't know if I'm being too anal on all the noise stuff, but hopefully it's all going to work. So I do have 12 volts to that jack, and the USB port still has continuity, so I guess we need to plug some stuff in, see if this bugger actually moves, and see if I can connect a USB port at 3.0 and see if I can actually connect to high-speed USB. Okay, mount's plugged in, computer booted up. I really haven't changed anything on the on-step controller, so it should just connect and have all of my settings, we hope. So here we have, we'll start up Nina. All right, let's see. Camera is offline, of course. So we'll go to mount. On-step telescope. And connect. Cross your fingers. And there we have it. Looks like it's kept all of my settings. So now we will go to the imaging tab. I'm just going to start out. We'll choose a target. And maybe the northeast just to start out with. Unpark the mount. We will go outside now. And I'll hit slew to target. And hopefully it moves. Oh, things are moving. Alright, hopefully nothing's gonna twist up. I did run super lube through all of the axes, so looks like it's just doing it. Everything seems to be moving correctly. All right, let's park. See if it goes back. So far, so good. I don't have the slew rate turned up really fast because I've never really cared about that. I go to one place every night and shoot, so. All right. Looks like it went back to where it was supposed to be. Okay, we'll try one more in the southern sky to make the deck axis a little more extreme. Make sure nothing gets twisted up. Southeast, slew to target. Oh, whoops. Error. And parked. And park. Now slew to target. Right. Everything looks like it's going to clear. That's good. All right. Back to park. All right. Right, back to park. First test complete. So we've moved inside for the rest of the testing because outside is raining and windy as usual. So I have good news and bad news. The 12-volt jack works great. Focuser jack works great. USB, not so great. So what I found out, talking to Gemini again, is that it led me on a wild goose chase. It told me that the cable going up through should be crossover when it should be straight through, because it didn't know how I was plugging the rest of the stuff in, it said. Anyway, so what I get to do is tear apart the saddle and resolder some of the pins and resolder the two pairs back to a straight through. I guess that will be like that. So here we go. So USB cable making has not been going well. I've tried probably 4 times now to try to get it to work. Doesn't seem to connect at USB 3.0 speeds. I did get it to connect at 2.0 for a while, but that's not going to do it for me. I've been getting to run around with AI. First it tells me to do a crossover, then it tells me to do it straight through, and it says I'm sorry. It led me astray. Anyway, most of my problem was, I think, my USB B, type B end. Pins didn't really map out to where they were supposed to be. I've been using these plugged into the ports so I can use my multimeter on the through holes to test them. Yeah, it didn't end up being correct at all. So I have bought just a panel mount. So I have this end, and then I'll cut the other end off of it. I'll run that up through my mount, and then just use a breakout board like this on the other end. So that should be easy to solder. As long as I keep my pins correct. I have finally found out that it is supposed to be straight through, with the B end on one end and this on the other end. Supposed to be straight through, pin to pin. And then my 2 commercial cables that plug into the computer and the camera are supposed to be just normal, and they cross over some way. Anyway, this is supposed to be B standard, so we'll try that. I have about given up about 5 times, but never give up, never surrender. So we'll be back. You do not know what this means. So you see the generic super speed hub. That is my SV Bony box. The AP2CC, that's my USB 3 camera. USB 2 cameras, my guide camera. This has been almost 2 months in the making. I have tried to make that cable probably 9 times. Finally, I got it. I guess we better try one more thing here. See if my camera still says offline, or if it says it's available. I will be a very happy person. Okay, that sucks. Maybe there's a different camera. Oh. Okay. That one shows up. Will it connect? Oh, sweet. All right. That's all I've been working for. And here's how I pulled off this grandiose accomplishment. So I bought this cable, which has these 2 ends. I thought I was having such a rough time soldering the breakout boards. I didn't know if they were going to work. I was thinking about maybe tearing this end apart and unsoldering and resoldering. And then I bought this panel connector for the on-step controller with this to plug into there. So the first thing I did was test this cable to make sure it worked. So I plugged this in between the 2 USB cables that I've been using to go from my computer up to my telescope to the SV Bony box, and this worked. So I used these kinds of breakout boxes to plug into these, and I tested all the pins, and they were straight through. So then I plugged this in to here, and I plugged in this stupid adapter that I've been testing with the whole time. goes in here, and then I just plugged this breakout board into that. And then I tested it, and I found out that this stupid adapter crosses over my transmit and my receive pairs. So all along I've been building crossover cables when it needed to be straight through. I took the cable that I already had run through, unsoldered the breakout board at the top, and resoldered a brand new one with the wires on the right pins, and lo and behold, worked first shot. Well, you may have wondered why I haven't posted for several weeks. Who'd have thought that a USB cable could become my arch nemesis? I spent several weeks buying things, trying things. Finally I got it though. So this is going to be quite a long video, but I wanted to keep everything in just so you guys could know everything I went through so you wouldn't have to do it. So hopefully the cable will keep up the 3.0 speeds even during shooting at night with the mount running. Hopefully the noise from the stepper motors won't interfere too much. I guess we'll find out in the next video whenever there's a clear night and I can get it out under the stars. Anyway, thanks for sticking around and watching this extra long video. As you could probably figure out, I haven't had a mount for a while, so I haven't been able to take any pictures. So I've been doing the reprocessing thing again. So check out the Jellyfish Nebula at the end of the video. I used all the cool new tools in Cyril. So that's all I've got for this time. Thank goodness. Talk to you later, and clouds suck.
Shooting from the yard, capturing the heavens when the signal's hitting hard. From the DIY mount to the open source code, I'm taking every photo on a long exposure road. Yeah, the focus is sharp and the mount is in flux, but we all know the truth. Clouds suck.